Good evening student. Today I will discuss about Ohm's law. So what done by Ohm's law? Ohm's law, it states that for a particular physical condition like temperature, pressure and mechanical strain, all are remains same or constant. At that case, the potential difference across the two ends of the conductor, which is directly proportional to current flowing through the conductor, or the current flowing through the conductor, which is directly proportional to potential difference across the two ends of the conductors. So Ohm's law states that current flowing through the conductor, which is directly proportional to potential difference across the two ends of the conductor. Under such physical condition like temperature, pressure and mechanical strain, remaining are constant. Okay? At that case, Ohm's law obeys. That means it states that current flowing through the conductor, which is directly proportional to potential difference across the two ends of the conductor, under such physical condition like temperature, pressure, mechanical strain remains constant or remaining constant. It means for a given temperature or given pressure or given mechanical strain, the current which flowing inside the conductor, which is directly proportional to potential difference across the two ends of the conductor. That means this is the conductor and the current which is flowing inside the conductor like as I. That current which is directly proportional to potential difference, that is V1 and that is V2. To V1 and V2. That means current which is directly proportional to potential difference. That means what? That means we can write in mathematical way. Mathematically, it is del V or I. Here we write I directly proportional to del V, or del V directly proportional to I. So if you remove the proportionality, you can write that del V which is equal to Ri. Here R is called constant, or R is called constant, and that constant only for ohmic conductor. Okay, it is for ohmic conductor, and that R represent as a resistance. But R represent resistance, Clear? Okay, so I directional to del V or del V directional to I. That means del V equal to Ri. Here R is the constant of proportionality and it is always constant for ohmic conductor and it is represented as a resistance. Clear? So what do you mean by ohmic conductor? Those conductor which are obeys Ohm's law, they are behaves as a ohmic conductor. Clear? That R is also known as resistance that depends upon resistivity of that material, length of the material, length of the conductor and area of the cross section. Okay, already I have discussed this one. That means R equal to rho L by A. So resistance always depends upon resistivity, length of the conductor as well as area of cross section. Clear? So why that becomes constant? Okay, why it becomes constant? Now I'll prove that one. How? As you know that in before class I will discuss about the relation between current and drift velocity. Okay, so please note it. After that I'll erase that one. Again I'll prove why resistance becomes constant in Ohm's law. Clear? Please note it. How resistance becomes constant, that becomes proved. How? We know the relation I equal to MEA VD. That means, or in other way you can write that VENA, VENA. That is the easiest way we can represent. Or NEA VD. That is, N means number of electron per unit volume, E is the charge of electron, A is the area of the conductor, VD is the drift velocity of free electron. Okay, you know that. In before class I will discuss this one. Clear? So I equal to NEA VD. Okay, and as we know that drift velocity equal to what? EV by ml into tau. You know that is I equal to NEA VD means what? It is EV by ml into tau. You know that is drift velocity. Drift velocity is defined as as a formula like as EV by ml into tau. So here you write VD equal to EV by ml into tau. That is the average. So E means charge of electron, V is the voltage or potential difference, M means mass of the electron, L is the length of the conductor and tau is the relaxation time. So relaxation time means what? It is a time in which there is a successive collision between the two electrons. It is the time interval for which there is a successive collision between two electrons. दुटा इलेक्ट्रॉन कोलाइजन होवा पूर्व जो जतेबेले कि इलेक्ट्रॉन जाक फ्री भाबे मूवमेंट करती से फ्री टाइम को कहा जाय कोन रिलैक्सेशन टाइम. सो हियर वी राइट दैट I by V equal to what? That means N E square A by ml into tau average, or V by I, which is equal to ml by Ne square A into tau. Okay, so here m is the mass of electron is always constant. That means the number of electrons which are present inside the conductor. So m is constant. L is the length of the conductor. For a particular value of, for a particular given length, we can assume the potential difference across the two ends of the conductor while the current flowing inside the conductor, so that the length of the conductor remains constant. N is the number of electrons which are present inside the volume, means number of electron per unit volume remains constant. E means charge of electron remains constant. A means area of the cross section remains constant. Tau average is always constant for a given temperature. So, but that MLA remains constant, but the three case, that is number of electron per unit volume and relaxation time, becomes constant for a given temperature. Clear? So that all are constant for, that is all are constant for a given specific temperature. Okay, already I have discussed this one. So that remains constant. So as we compare that Ohm's law, that means V by I equal to what? That is R. So R can be represented like that. So R, which is equal to ml divided by n square A into tau. Clear? Clear? So R remains constant only for ohmic conductor. Those conductor which are obeys Ohm's law, at that case resistance remains constant. But any other substance except ohmic conductor, their resistance becomes vary. Clear? Clear play? Like a semiconductor, alloys like that. Clear? So that is the proof of resistance, and that is also a constant quantity. Clear? So here we write V, which is equal to Ri. This is Ohm's law. For a given temperature, temperature remains constant. Please note it. So V equal to Ri. Here, this is the scalar form. Now it also written as in vector form. In vector form. In vector form, we can write that, you know, V by I, which is equal to what? ml by ne square tau. ml by ne square a tau. Clear? Okay. Now here we write that, that means V equal to ml I by ne square a tau. Clear? Now that L, which is moving towards left side, and it is in form of denominator, so we can write that V by L, which is equal to m by ne square tau into I by A. Clear? Clear below? V by L means E, that is the electric field. That is, as you know that E equal to dV by dr. This is the relation. So dV can be represented as a V and dr can be represented as L. So E can also be represented as V by L. So this is the representation. So if you put the value of V by L, can be represented as E equal to, that's some constant quantity m ne square tau into I by A represented as J, as we know that. In before class I will discuss about J. J is a vector quantity whose name is current density, that can be represented as I by A. Current per unit area represented as J. Okay, and that represent is m by n square tau can be represented as what? Resistivity of the material. Okay, so that implies E equal to, that is rho j rho j. So E vector, that is electric field, is a vector quantity, j is also a vector quantity. That means, okay, m n square by, okay, that is the one type of form of what? Vector form of Ohm's law. That is E vector equal to rho into j vector. In other way, you can write that j vector, which is equal to rho sigma into E vector. So this is the another form of Ohm's law, vector form. This is also a vector form, this is also a vector form. Here sigma, which is equal to reciprocal of resistivity, that is the conductivity. Conductivity, which is equal to reciprocal of resistivity. Here sigma represent as a conductivity of a material, and it also reciprocal to resistivity. Rho is the resistivity of a material. Okay, so sigma is called conductivity of a material. Okay, and rho is called resistivity of material. So conductivity and resistivity both are properties of material, which that sigma which conducts the electricity, where the electricity or current pass through it, that means it is the ability. Similarly, resistivity, it is also a property of material. So conductivity and resistivity both are reciprocal to each other. Clear? So this is the vector form of Ohm's law. Okay, this is the vector form of Ohm's law, and V equal to Ri is the scalar form of Ohm's law. So here E equal to m by n square tau, which is equal to into j. So that gives E vector equal to rho into j. This is also a vector form, this is also a vector form. Only that resistivity is the reciprocal of conductivity, so we can write j equal to sigma E. Clear? So this is all things which are represent in Ohm's law. Clear? So again I'll repeat, sigma is called conductivity of a material, which is the ability to flow the current, and resistivity is the ability to oppose the current for unit area and for unit length. Okay, that is also for unit area type. Resistance, you know that resistance is the net opposition to oppose the current, where the current pass through the conductor. Similarly, conductance is also there. That conductance is also represented as like as a G. That is called conductance. Okay, so conductance is also to flow the current, where the current pass through the conductor. That means resistance, which is equal to reciprocal of conductance. Similarly, conductivity, resistivity is also reciprocal of to conductivity, or conductivity which is also reciprocal to resistivity. So resistance, that is called G, means conductance. Both are reciprocal. Similarly, resistance, resistivity as well as conductivity both are reciprocal. Okay, these are the properties of the material, but this is the opposition, or this is the ability to flow the current inside the conductor, this is the ability to oppose the current inside the conductor, and these are the properties. So that depends upon area and length of the conductor. Clear? Now we now plot a graph between voltage and current in different substance. So please note it. After that I will erase that one. From Ohm's law, we plot a graph between V along x-axis and current along y-axis. So for ohmic conductor, the graph represents straight line graph. That is the linear graph. For ohmic conductor. Okay. Del theta. So in ohmic conductor, del V by del I, that means del V by I, which is equal to constant. Those substances which could not obey Ohm's law, they are behaves as a non-ohmic conductor. Okay. For non-ohmic conductor, we can write the graph. So this is the second graph. Voltage along x-axis and current along y-axis. The graph is like that. If you increase the potential at a particular potential, at a particular given potential, the graph is like a linear. After, if you increase the potential, the graph is like that. So that is obey non-linear curve. So that could happens only in non-ohmic conductor. So this is only for conductor, that is obey Ohm's law, that is the linear curve. For non-ohmic conductor, this is the graph. Sometimes it becomes linear, after that it becomes bending. So it represents as a non-ohmic conductor. Similarly for semiconductor, already you know that. Clear? Already you know that in semiconductor the graph is like that. The graph is like that. So this is for semiconductor. That is voltage along x-axis, current along y-axis in milliampere. And this is current along microampere. This is the voltage. Bias, that graph is like that, and in reverse bias, that is graph is like that. Okay, that is the reverse bias. You know that in semiconductors chapter, in p-n junction diodes. Clear? Similarly for gas, it given like that, there is voltage and current. It plots in gas, for gas. Okay, so at first it becomes increases linearly, after that it becomes irregular shape. After certain value of potential, it becomes decreases, again it becomes straight. So that in that case, that is for gas, resistance becomes negative. Resistance become negative, like this. So this is the graph, that is downward flows. Due to downward flows, that is V by I becomes decreases. So it becomes what? Negative. So it is always I by V equal to 1 by R. Negative. Clear? This is for yes. So this all these three graphs, this one, figure A, B and C, all are behaves as non-ohmic conductor. Non-ohmic conductor. Clear? Three graphs. 1, 2, 3 behaves as a non-ohmic conductor, but that graph behaves as a ohmic conductor. Ohmic conductor, which represent a graph, is a straight line, not as a non-linear. It is a linear graph. Here, but in non-ohmic conductor, the graph is particular value, it becomes linear, after that it becomes non-linear. So this is like that, and that is for semiconductor, and that is for gas. For gas, it becomes increases for linearly, after that it becomes irregular, again it becomes decreases. So in gas, the resistance becomes negative. Clear? So this is all about Ohm's law in scalar form and vector form, and it also and their characteristics by using different graph for linear, for ohmic conductor and non-ohmic conductors. Thank you. If any doubt, then ask me. Okay. So overally you can note it in your notes. Clear? Thank you.